Organic chemistry. Organic chemistry is a branch or a sub-discipline within chemistry involving the scientific study of the structure, properties, and reactions of organic compounds and organic materials. And by saying organic compounds, we are just referring to carbon containing compounds. Compounds that contain carbon are organic compounds, except the carbonates and then the oxides of carbon are not organic compounds. For example, carbon dioxide is not an organic compound, although there is carbon here. Carbon monoxide is also an oxide of carbon, but it's not an organic compound. Then hydrogen triazocarbonate is also not an organic compound, although it contains carbon. So this is a carbonate of carbon. There's carbon here, but it's not an organic compound. There are other examples like metallic cyanides. Although metallic cyanide, sodium cyanide to be specific, contains carbon, it is not an organic compound. There are more examples of compounds that contain carbon but are not organic compounds. So you can actually look them up or check them. All these examples we've mentioned, they are actually inorganic compounds. Organic compounds like proteins, fats, sugars, and co are found all around us, and they play a crucial role in living things, in the life processes of living things. And it is very hard to think about how life would be like without these organic compounds. And then our life actually revolves around substances that actually contain organic compounds. For example, the food we eat, the medicine we use when we are sick, the fabrics we wear, the plastic and rubbers that we depend on, and petroleum that we actually need in our vehicles all contain organic compounds. So our lives, from the time we wake up early in the morning till we go back to sleep at night, we actually depend on organic compounds. Compounds that contain carbon or organic compounds are the largest group of chemical compounds that are known in nature. And this is as a result of a certain unique property of carbon. So because of this unique property of carbon, it is able to form so many millions of compounds which are organic compounds. And these properties, we are going to touch on three of them. The first property of carbon that makes it unique is that it is found in group 4 of the periodic table. And what that means is that it has 4 valent electrons, and as a result can form 4 covalent bonds with other elements. This is what it means. If you pick carbon, for example, it has an atomic number of 6, which means that if we want to write out its electronic configuration, we are going to write 2, 4. 2 in the first shell and 4 in the second shell. So in the second shell or the last shell, we have 4 electrons out there. So if I write it out this way, showing only the electrons, we are going to have something like this. So these 4 electrons can go into bonding with other elements. And then the next unique property of carbon is that carbon can actually join with other carbon atoms to form stable straight chains or branchings or even rings. This is a unique property of carbon that no other element has. So carbon can actually bond with itself to form long chains of carbon. And these long chains of carbons that are formed can either be straight chains like what you've seen here, or maybe branch chains like this. It can branch out this way. Good. So branch chains, or even carbon can form rings, something like this. So we have this. No other element can actually do this. And this unique property of carbon makes it so versatile at forming millions of organic compounds. No wonder organic compound is the largest group of chemical compound that is found in nature. And the next unique property is that carbon can actually form single, double, or triple bonds with other carbon atoms and also atoms of other elements. So carbon can form double bond or single bond. And the double and triple bonds are known as multiple bonds. So you might come across that carbon can form single or multiple bonds. And multiple bond simply means double or triple. So carbon can form single bond like this, or double this way, or triple this way. Good. So it can form these bonds with other carbon atoms or atoms of other elements. For example, we can have this hydrogen over here. So the single bond exists between the carbon and hydrogen. We can have carbon double bonded to oxygen, or we can have something like this. Good. So carbon is so versatile, and this unique property of carbon makes it possible for the existence of millions of organic compounds. There are actually millions of organic compounds in nature, as stated earlier. And one reference work states that by 1998, about 7 million organic compounds were known by 1998. And now we are in 2024. You can just imagine the number of organic compounds that must have been discovered from 98 till now. And this is the largest group of chemical compounds that can be found in nature. So these millions of organic compounds can actually be put into different families based on the physical and chemical properties that they have. And these families, we are going to mention 5 of them. The first one is hydrocarbons, you have alkanols, alkanoic acids, alkanates, fat and oil. So hydrocarbons, alkanols, alkanoic acid, alkanate, fat and oil are all collectively known as organic compounds. So all hydrocarbons are organic compounds, but not all organic compounds are hydrocarbons. So in the next video, we'll actually be talking about each of these families of organic compounds. We'll pick them one at a time. Now, each of these family of organic compounds is known as a homologous series. So the hydrocarbon here is a homologous series. We have the alkanols as a homologous series. We have alkanoic acid, alkanates, and fatty oil as homologous series. A homologous series simply refers to a group of organic compounds consisting of series of compounds in which all the members can be represented by the same general formula, but they differ from the next in the series by unit of CH2. And CH2, that is methylene, a methylene group. Do not worry too much about understanding what this means, because in subsequent videos, this homologous series is actually going to make sense as we look more by taking each of them, hydrocarbons, alkanes, taking them one after the other. The definition will make more sense to you. But basically, homologous series refers to a group of organic compounds consisting of series of compounds in which all the members can be represented by the same general formula. That is what I want you to keep in mind. And compounds in a homologous series have the same chemical property simply because one, they have the same general formula, and another reason we will see later. So they have similar chemical property, and the next is there's a gradual increase in molecular weight. There's a gradual increase in molecular weight. And then there's a constant difference in molecular weight between successive members. In other words, each member of the series differs from the previous one by a fixed number of atoms. Also, at this level, don't worry too much about understanding what this means. Just know it, because in subsequent videos, I think the next or the third, these points are actually going to make sense to you. And all members All members of a particular homologous series have the same functional group. All members have the same functional group. And the functional group is basically an atom. It can be a single atom, just one atom, or group of atoms, or just a bond, which gives a particular family of organic compound its characteristic chemical property. We mentioned five families of organic compound in previous slides. Each of them is a homologous series, and each of the homologous series has a unique functional group, and it is this unique functional group that is responsible for the characteristic chemical property of the homologous series. Also, do not worry too much about the functional group, because we'll be looking at the functional group of each of these homologous series as we proceed. As a way of analogy, as you remember, homologous series are basically the families into which organic compounds are divided into. So if that is the case, then functional group is the surname. So if homologous series is the family, then functional group is the surname. What that means is that all organic compounds belonging to the same homologous series have the same functional group. For example, let's assume we have the Jackson family. Jackson is the surname. So in this scenario, Jackson becomes the functional group. Then we have the Jackson family. So we can have Michael Jackson is a member of the Jackson family. We can have Gideon Jackson, we can have Jordan Jackson, we can have Sarah Jackson, we can have Alicia Jackson, Benjamin Jackson, Edmund Jackson. So one interesting thing is they all have the Jackson as part of their name. So the Jackson becomes the functional group, or in our scenario, the surname. Then each of them is a member of the family. And in this case, the family is the homologous series. So for any particular family of organic compounds in a homologous series, the reactivity of the compound depends on the functional group. And in subsequent videos, we are going to look detailed into it. So this brings us to the end. So this brings us to the end of this video. In the next video, we'll be talking about each of the functional groups, and we'll get to understand it into detail. But we'll first start off with hydrocarbons. So come back for the next video.